Hello class, let's analyze now the case of collisions. Some examples of collisions are the collisions between two billiard balls, the collisions of galaxies, and the collisions between atomic particles. So you can see collisions happen at all size scales in the universe. The amazing thing about conservation of momentum in collisions is that it applies to some situations where Newton's laws cannot be applied. For example, in the collision between atomic particles, Newton's laws cannot be applied. We need to use instead the much more complex laws of quantum mechanics. However, conservation of momentum can be applied to the collisions of particles as well. We can classify collisions in two different types. The first, elastic collisions, are collisions between very rigid objects, such as the collision between two billiard balls. After the collision, these objects will bounce and move away from each other. In these types of collisions, momentum is conserved and kinetic energy is conserved. The second type are inelastic collisions between soft objects. When soft objects collide, sometimes they might stick together and sometimes they might bounce away from each other. In these types of collisions, momentum is conserved. However, kinetic energy is not conserved because energy is lost as the shape of the objects is modified due to the collision. So think about a car crash. When two cars crash, many parts of the cars are broken, other parts of the car are crushed, and in both processes, heat energy is produced and lost into the surrounding media. As an extreme case of inelastic collisions, we have the so-called perfectly inelastic collisions. This type of collisions happen when two objects collide and stick together. So after the collision, they move as one single object. In this type of collisions, energy is not conserved because in the process of sticking together, heat is generated and then lost into the surrounding media. Momentum, however, is conserved, and we can write momentum as follows. For the initial conditions before the collision, the two objects approach each other, and we can write the total momentum of the system that consists of objects A and B in the diagram as the momentum of object A, mass times velocity, and momentum of object B, mass times velocity of object B. After the collision, the two objects move together as one single object. So the total mass of the new object will be the sum of the masses of the two separate objects, and since these objects move as one single object, they will have the same velocity that we can represent as the final velocity. So this is the equation for perfectly inelastic collisions that happens when objects stick together after they collide. Let's now analyze the case of elastic collisions. Remember, these collisions happen between very rigid objects such as two billiard balls, so that when they collide, the objects do not suffer any deformation, and for that reason, no kinetic energy is lost. So, since kinetic energy and momentum are conserved at the same time, we can write the two equations for conservation of momentum and conservation of kinetic energy. So conservation of momentum has the momentum from object 1 and momentum from object 2 at the initial time. So the sum of these two components will be the total initial momentum. We have equivalent expressions on the right side of the equation to calculate the momentum of object 1 and object 2 at the final time, and when added together we have the final total momentum of the system. And the initial and final momentum must be equal. Since kinetic energy is conserved as well, when we add the initial kinetic energy of object 1 and the initial kinetic of object 2, we get the total initial kinetic energy, and on the right side an equivalent expression for the total final kinetic energy. When we combine these two above equations and we assume that the initial velocity of object 2 is 0, so initially the object 2 is at rest and object 1 is approaching object 2 before the collision. So assuming these conditions, we combine these equations, we do some algebra, and we will get two equations to find the final velocity of object 1 and the final velocity of object 2 in terms of the initial velocity of object 1 and the initial velocity of object 2 doesn't appear here because remember the initial velocity of object 2 was 0. So all we need to know then to find the final initial velocities of object 1 and 2 are the initial velocity of object 1 and the mass of each of those objects, so mass 1 and mass 2.